Hey guys, it's Mr. Finn. I'm back in the lab. Trying to give you some data to go along with the lab handout that I gave you through Canvas. So this is experiment 12. This is constant force changing mass. All right, so the first thing we got to do is we got to check out our setup here. I've got a dynamics track. This cart moves along the track. Pretty low friction, right? There's a string attached to this cart, goes over a pulley, and there's a little tiny mass, a 20-gram mass, that's going to pull this cart along. So if I let it go, the cart will accelerate along the track because the 20-gram mass is pulling it down. So my constant force is the 20-gram mass. If I cut the string, the 20-gram mass would be in free fall. But we're not doing that. The 20-gram mass is accelerating this cart and itself, so the system. All right, so previously I leveled the track to make sure that it wasn't going downhill or uphill. These bar masses are 500 grams apiece. The cart that I'm using is also 500 grams. So 500-gram cart, each a bar is 500 grams, and then I've got some additional masses in this mass set here. 20, 50, 100, 200. What I'm going to do is do some trials for you to put in your data table so that you can make some graphs and answer some questions. I'm going to start this at about 130 centimeters on the track, and it's going to end at about 210. So this thing's going to accelerate for 80 centimeters of movement. I'm going to time it. So I'm going to create the acceleration from 130 to 210. So when this cart bumper hits this, I'm going to stop my stopwatch. But I'm going to put some mass in here. So I put one bar in. I've got a 500-gram cart plus 500, so I have 1,000 grams in the cart. Okay, try to do this all at once. Now, in your data table, it has spots for 3 trials. I'm just going to do one. Okay, ready? Go. Okay, that was 3.25. Actually, I might as well just do another one just to make sure. 3.25 was my first time. 3.25 seconds. Ready? Go. 3.11. So we're pretty close. So that's with 1,000 grams in the cart. Now let's do 1,500 grams in the cart. So I've increased my mass by 500 grams. Ready? Go. 3.904. So this would be like the next run. This is the next horizontal run in your data table. Ready? Go. 3.871. So 3.904, 3.871. So now I have 2 runs done. The first one, the second one. But I want to fill in some other runs. So why don't I take one of the masses out instead of, now I've got 1,000 here, I've got 1 bar, and the cart itself has 1,000. I'm going to put the 200 in here. So now I've got 1,200. It's not exactly halfway in between. I guess I could make it halfway in between. 250. Now I have 250 in the cart. So I have 250 plus the 1,000. So I have 1,250 in the cart. It's exactly halfway in between the 2 trials I just did. Ready? Go. 3.429. Let's try one more trial, that same one. Ready? Go. 3. Oh, I screwed that up. Sorry, I was looking at you. Let's try that one again. Ready? Go. I was looking at you and it didn't stop the stopwatch. 3.429. That's pretty close. All right, so now I've got 3 runs done. So in your data table, you should have 3 sets of entries, 3 rows of entries. Now, let's go down to just the 500 and the 250. Okay? So now I'm down to 500 plus the 250, so 750 grams. Ready? Go. 2.55. Let's try it again. Ready? Go. 2.57. All right. Now I'm going to try one more. I think I have two more runs to do. I'm going to try just the card itself. So this is just 500 grams. 500 grams. Ready? Go. 2.13. Let's try that again. That was 2.13. Ready? Go. 2.11. All right, I need one more trial, I think. I've done 4. Oh, I need 2 more trials. All right, so let me go 2 more runs. So let me go 1,500 plus a 200. Now I got 1,700 grams. Man, this is going to be slow. Ready? Go. .37. Let's try that again. Ready? Go. .33. All right, we're really getting slow now. Let's put another 200 on there. So we are at 500 plus the 2 bars is 1,500 plus the 400 is 1,900 grams. Still, the 20 gram mass is pulling it. Ready? Go. Look how slow it is. 4.679. All right, one more. Ready? Last one. Go. 5.025. Okay, guys. Now with those runs, you should be able, remember my distance was 80 centimeters. You should be able, using the kinematic equation, distance equals 1/2 AT squared, or 2D over T squared will give you acceleration. You should be able to fill in that acceleration column. Now, from there, you need to graph. And I believe it says to graph under analysis 1, which is basically question 1. Describe your graph of acceleration versus mass. I'll be showing you what to do in a graph situation in our next Google Meet. But graph of acceleration versus mass for experiment 12. And I'll describe the other one the next time out, experiment 13. Okay, guys, have a great day.